In this tutorial, we take a look at the Toolpath template feature, which is designed to save time in creating toolpaths for sets of vectors in similar jobs. We're going to show you how we can achieve this by organising vectors into layers and setting up the toolpath to use the automatic vector selection option, where we associate the vectors in the layers to the toolpath. If you find yourself creating the same jobs over and over again, you may find that creating a toolpath template will really help you save time in the long run. So let's go to File, Close, then we're going to open an existing file. So from your Nested Cabinet Files project folder, we're going to open the sample cabinet.crv. Okay, so here we have a set of vectors that have been specifically created for this particular demonstration, just to show you how to set up a toolpath template which we can use on similar jobs in the future. Now, we don't have to use vectors like what we have here that were originally created in a specialist cabinet design package. We can also look at creating our own vectors by using many of the drawing and editing tools that we have in the software. Now, the key to creating a toolpath template is actually in the organisation of our vectors. So if we just jump to our Layers tab here, so you can see in our example we have quite a lot of layers here, and each of these layers have vectors relating to a certain type of toolpath. Now, the way that we want to organise our vectors is to group them by how we plan to cut them, and then we can look at using the automatic vector selection option in the toolpath to select certain types of vectors from a particular layer. So the layers that you can see on the screen have been imported along with the vectors that come in a DXF format from this cabinet maker's design package, where it's retained that layer information. And so any further cabinets that I decide to make in the future in this particular software, when I come to import them in, it will have the same layer information and the vectors relating to those layers, so that when we do come to utilise the toolpath template, it's going to look for the particular vectors that we specify on the particular layer that we've selected and then apply a toolpath to them, which in the long run will save us a lot of time. So let's take a look at the layers and see what we've got. Okay, so starting at the top, you can see that we have 3 different layers that are all relevant to holes. And each one of these layers is going to have a different toolpath associated with it. For example, the shelf holes are going to be cut using the drilling toolpath, cut into, let's say, 1/4 of an inch. Whereas the drawer holes, we're also going to use the drilling toolpath, but they're on a separate layer because I may want to cut deeper or shallower than the shelf holes. You can see then we have 6 different types of dados, so we have 6 dado layers, and each one of these layers is going to have a different toolpath associated with it. Now, even though they might all have the same settings specified in the relating toolpaths, it's still handy to keep them organised separately in case one day we decide to change the cut settings to one of the dados, then we don't have to manually edit the toolpaths for the other dados that we have at different cut depths. And so it makes sense to just keep them all separate. So looking in the layers list, I can see, judging by this icon, we have vectors on all of the layers. Okay, now if we had a layer where there were no vectors on there, we'd be displayed with a blank page. Okay, so to select the vectors, what I could do is double click on that page icon, and you'll see that it's selecting all of the vectors for the hinge holes layer. If I double click on the shelf holes layer, you'll see that now these vectors are on the shelf holes layer. Another way to do this, I could right click on this option here and use the option to select layer vectors, and then it will display all the vectors for the drawer holes. So we've got this one here, and these 2 there. Another way I can do that is by actually selecting the layer name. That will make it the active layer. It makes it bold. It's now the active layer. We can right click on the name also and use the Select Layer Vectors option, we can see those vectors belong on the side blind dado layer. So there's lots of different ways that we can actually access the vectors for a particular layer. So now we're going to look at sizing up the vectors to decide what type of toolpath we're going to be applying to them. For example, let's just select this vector over here. Now, with that vector selected, you'll notice at the bottom of the interface, the software is telling us some information about that particular vector that's selected. We're displayed the width, the height, and what layer this vector belongs to. So we can see it belongs to the bottom blind dado layer. Now the nice thing about this is that we're given the information in terms of the width and the height of the part, and this will help us to determine what sort of toolpath we want to use. Now I know that I'd like to use a 3/8 inch end mill to cut this dado out, and we know that the width of the vector isn't more than twice the diameter of the 3/8 inch tool that we plan to use. So we could look at using a profile toolpath to cut this out on the inside, and this would be much quicker and more efficient for me to use a profile pass on the inside of this vector than if I was to pocket all of this. So let's now look at this vector here. So we can see this is a little wider than the width of the vector we were just looking at. So at the bottom, so we can see that vector belongs on a layer called back bottom dado. We have a width of 14 3/4 inches and a height of 0.7820. And so in this case, I'd look at using a pocket toolpath on this, as the height is more than double the diameter of the tool that I plan to use. And this really is more for efficiency from a machining point of view. Okay, so I've gone around and I've checked all of the vectors on all of the layers and ordered the layers for organisation, where the top 3 dados that we've got here will be using a profiling toolpath, and the bottom 3 dado layers will look at using the pocketing toolpath. And so at this stage we can actually switch over to the toolpath tab and start applying our toolpaths. So we'll just switch over. So the first thing that we're going to do is check over our material setup, ensuring that it matches that of the part that we actually intend to cut, along with checking over parameters and settings, ensuring that they're safe and appropriate for our material and the machine that we're using. So material thickness we're working with is 3/4 inch. We're going to set our X0, Y0 position in the lower left hand corner. You can see that highlighted over here. We're going to set our Z0 position on the material surface. Check over your rapid Z gaps above the material, your clearance, plunge settings, home start position and your Z gap above the material are all safe for your own setup, and then you'd go ahead and press OK. So we're going to start with a simple drilling toolpath. So we want to make sure that we have no vectors selected here, as we're going to use the automatic vector selection option to automatically select our vectors for us within the toolpath. So just to make sure, let's just click into the white space, and then we're going to go straight into the drilling toolpath. So we'll start by assigning the cutting depths. So for the start depth, we're going to start that at 0. Cut depth, we're going to cut down 1/2 inch in this case, and we need to select a tool. So we need to use the select option here to open up the tool database. In this case, we're actually going to use a drilling tool. So we'll use the drill bit here. Okay, so we've got the 1/4 inch drill. Check over the settings, ensuring that they're safe and appropriate for your application. And so I'm going to go ahead here and press select. Just going to uncheck this option to use PEC drilling. We're just doing a basic drill toolpath here. And then at the bottom, you'll see we have the option vector selection. It's currently set to manual, which means that we need to go in and select the vectors to associate with this toolpath. However, we want the software to do that for us. So we're going to use the selector option here. And so this vector selector enables us to specify various filters which will enable the software to select the vectors for us based on the rules that we apply within this form. So let's start off on the left hand side. So in this case I want to select all of the closed vectors. Okay, so we're just going to uncheck the open vectors option, whereby I want to select only the circles. Okay, I know that we're going to use the drill toolpath on the circles for the hinge holes layer. So we're going to tell the software we want to select only the circles and then select all the circles within a particular layer. In this case, you do have further options if you wanted to be a little bit more specific, whereby you could select the circles matching the tool diameter of the tool that we're using. Or you could select circles matching a circle diameter and a circle tolerance that you specify in this form. In this case, however, I want the software to pick all the closed vectors that are only circles on the hinge holes layer. And so we can see in the 2D view, it's actually pulled out the vectors that abide by these rules, so all the closed vectors, only circles on the hinge holes layer, and it's automatically selected those for us there. And if we want to use this efficiently in a toolpath template, then what we need to do is associate all of the rules with this particular toolpath. So if we then go to use this when we load in a toolpath template in future cabinets that we make, when it loads in that toolpath, it will remember to select the vectors according to these filters. So we're going to make sure that we associate these filters with this toolpath. So we're going to check that option there, and then we can simply close out and it will assign all of those rules to this particular toolpath. And so once we've done that, rest assured that when we recalculate this toolpath, it will look for any vectors that abide by that set of rules within the hinge holes layer. So let's just go to the layers bar at the top, and all I'm going to do is take the hinge holes layer, click it again just so that the text is selected. I'm going to right click, I'm just going to copy the name of that layer. We're just going to apply it to the drill toolpath name. So we're just going to paste that in. So we've got drill hinge holes, and then we could go ahead and press calculate. Okay, so you can see the travel of the toolpath here and where it's going to plunge down into, and then we could go ahead and preview that toolpath so you can see our set of drill holes here. Right then, so let's just go ahead and tile our windows horizontally, and now we'll move on to the next set of drill holes. So let's close out. Okay, so we're just going to click into the white space, so no vectors are selected. We're going to go back into the drilling toolpath. Okay, so here we're going to go again, go with our start depth of 0, cut depth of 1/2 inch. So the software's remembered the cut depth that we used previously, which is okay in this case. Then we need to specify our tools. So back into the tool database, we're going to take that drill tool, press select, and then again we're going to select our vectors using the automatic vector selector option. So use the selector option here. Okay, so we're just going to look at the rules that we want to assign in this case. Again, very similar, we're going with closed vectors, only circles, select all the circles, except this time we want to select them from the shelf holes layer. Then what we want to do is we want to assign all of these rules, and we want to associate that with this toolpath. So we're going to check this option here, and then we can simply close out, and again we'll just go up to our layers bar at the top. I'm just going to double click on the shelf holes, right click, copy that name, and then on the drill we're just going to delete the one there, and then we'll just paste in the name there for drill shelf holes. We can see the software's automatically picked up those vectors based on the options that we had in this form here. And so now we could go ahead and press calculate, and then we could go ahead and preview that toolpath. We can see the added drill shelf holes in our preview there. Right, so let's close out, This time we're going to click back into the white space and we're going to go back into the drilling toolpath. And again, we're going to have a start depth of 0, cut depth of 1/2 inch, select our tool from the tool database, and then we'll go into the selector option here. This time, again, all closed vectors, only circles, select all circles, uncheck shelf holes. This time we want to look at the draw holes layer. And then we want to associate these rules with this toolpath, so we'll check that option there, close out, over to our layers bar, double click on the draw holes layer, right click to copy the name of that layer into the name of our toolpath, delete the number 1, and then we're just going to paste in that layer name. So we have drill draw holes, and you can see the vector selection is set to automatic and it's pulled out those vectors over here. And then we could go ahead and calculate those vectors, preview that toolpath, and there we have all of the drill holes previewed and simulated here in the 3D view. So now that we've created the holes toolpaths, we can now move on to the dados. Now, as I said, the first lot of dados that will be created will be using the profile toolpath to do this, using that 1/8 inch end mill. So let's just close out of there. We're going to go click into the white space, so we have no vectors selected, and we're going to go into the profile toolpath. So again, we're going to start by looking at our cutting depths. We'll start that at 0, and we're going to cut down 3/8 of an inch. Okay, so the decimal value for that is 0.375. Then we need to specify a tool, so we use the select option to open up the tool database, and as I mentioned, we are using the 3/8 inch end mill. Check over the settings, ensuring they're safe and appropriate. You can see it's going to cut that in one pass. Then we need to specify how we machine the vectors, whether that's outside, inside, or on the vectors. In this case, we want to go inside of the vectors there. Then we can jump straight to the bottom to the vector selection option. So we need to change that so that it automatically selects the vectors based on the settings that we're going to apply here. Okay, so in this case, we do want all of the closed vectors. We know we're not dealing with circles here, so we're going to use this option, all closed vectors. Okay, then we need to come over to the right hand side, uncheck the draw holes layer, and this time we're going to check the bottom blind dado layer. And so now we want to associate these rules of selecting all the closed vectors that are on this layer, so we want to associate that with this toolpath. So then we can close out here. And then over to the layers bar at the top, we're going to go to the bottom blind dado, double click on that, right click to copy the name, and then we're going to go into the name and we're just going to delete the number 1 there, paste in the bottom blind dado. We're really just copying the name for our own benefit so that we know what area we are cutting, and then we could go ahead and press calculate. Okay, and so it's picked up the vectors for the bottom blind dado based on the settings that we applied in the vector selector form. And so here we could go ahead and preview that to see what that looks like, and then we can close out and move on to the next toolpath. So click into the white space, we're going to go back into the profile toolpath. And so again, we're going to go the same settings, same cut depth. We're going to select the tool, so we're going to take that 3/8 inch end mill into machine on the inside of the vectors, go into the vector selector option, and we want to find all the closed vectors on the side blind dado layer. So we're going to check that layer. We can see that it's highlighted the vectors for that layer. And we want to associate these rules with this toolpath. So we'll check that option there, close out, and we're going to go into our layers bar, double click on the side blind dado layer, right click to copy the name of that layer, and we're just going to go into the profile and we're just going to right click, we're going to paste in the side blind dado to put to that name, and then we could go ahead and calculate that, and then we could preview that toolpath and see the result of that there in the 3D view. Let's close out, click into the white space. We're going to look at the last profile toolpath now. So back into the profile toolpath. Again, same cut depth, into the tool database. We're going to select the 3/8 inch end mill. We're going to machine on the inside. Using the vector selector option, we're going to use all closed vectors, uncheck the side blind dado and make the top blind dado the active one. We can see those vectors are highlighted here. We want to associate these rules to this toolpath, so we're going to check that option there, close out, into our layers bar, double click on the top blind dado and then right click to copy the name of that, and then into the name of the toolpath we're going to delete the number 1, right click to paste in the name of the top blind dado, and then we could go ahead and calculate that, and then we could preview to see how that part looks. So now we can look at the pocket dados, as the width of the dados were more than twice the diameter of the 3/8 inch tool. So let's close out. So now we're just going to click into the white space, and this time we're going to use the pocket toolpath. So here we're going to have a start depth of 0, we're going to have a cut depth of 3/8 of an inch. Tool we're going to use that same 3/8 inch tool, select that. Okay, just going to uncheck this option here to use large area clearance tool. We need to choose how we clear the pockets. Okay, so in this case we're actually going to go in a raster strategy. Now I know that the dados we're cutting into now are all the horizontal dados, so we're going to keep our angle at 0 so that it goes along the x-axis. Okay, then at the bottom here we're going to use the vector selection option, use the selector. Okay, so here we're going to go with all the closed vectors, and then we're going to specify the back bottom dado here. We want to associate all of these rules with this toolpath. Okay, and so if I just move that, we can see that this vector has been selected there. Okay, we can close out. Into our layers tab, let's double click on the back bottom dado, right click to copy the name, into our toolpath name, delete 1, right click to paste in the name of the dado, and then we could go ahead and calculate that. We can see that there, and then we could preview that and see how that looks. Let's close out of the preview toolpath form, click into the white space, and we'll go back into the pocket toolpath and we'll look at the next dado. Okay, so again we're going to go the same cut settings in the tool. We're going to select the 3/8 inch tool there. Again we're going to raster that at an angle of 0 degrees. Using the selector option, we're going to select all the closed vectors for the back side dado. Okay, and again you can see it's updated in the 2D view which vectors it's pulled from that layer. And we're going to associate that with this toolpath, close out there, into the layers bar. Let's just use that scroller to bring that down, double click on the backside dado, right click on the name, we're going to copy that name into the name of the toolpath, delete the number 1, right click, paste in the name backside dado, calculate that, preview that. We can see the two parts there. Close out, click into the white space. We're going to look at creating the last pocket toolpath now. So back into the pocket toolpath. Again, the same settings. We're going to use the same tool. Into the selector there. We're going to use all the closed vectors for the back top dado, so we can see that's selected there. We want to associate these rules with this toolpath, so we're going to associate that with the toolpath, close out, and then into the layers bar. We're going to double click on the back top dado, right click, and we're going to copy that, and then in the name of the toolpath we're going to delete the number 1, right click and paste the back top dado in there, calculate that, and then we could go ahead and preview that toolpath. Now this may seem like a lot of work what we're doing here, but it will pay off, as all we have to do is create this set of toolpaths once, save out the toolpath template, and then when we import the vectors that were created from our design package, we simply apply our toolpath template, recalculate the toolpaths to the layers that we've imported, and so it will make work life a lot simpler and faster in the long run. Just takes a little bit of time in the initial setup. So let's close out and we'll look at running the last toolpath, which is the profile cutout toolpath. So we're going to go into the profile toolpath, start depth of 0, cut depth. This time we're going to cut all the way through the material. So put in Z equals, and the software will input the material thickness that we assigned in our material setup form. Tool, we need to select the 3/8 inch tool that we've been using, so we'll select that one there, and this time we're going to machine on the outside of the vectors to ensure that we're cutting the parts out. Okay, and then moving on down, we're going to go into the selector option here. And so here we want to select all of the closed vectors and all closed vectors for the cut layer. Okay, so by selecting this option here, this is beneficial as you can ensure that you're only cutting on the outside of a closed vector, whereas if they were open, depending on their start and end position, would determine which side of the vector is outside and inside. So we're going to make sure we have all closed vectors on the cutout layer where we're machining on the outside of those vectors. We're going to associate these rules with this toolpath. Okay, so we'll close out there. The name for this layer is cut, so in here we're just going to go profile cut, and then we could simply go ahead and press calculate. We can see it's pulled out all of the vectors there. We can see all of the previews here, and if we preview the toolpath is to simulate what our part would look like when we come to cut it out, this is how it would look. Okay, and so what we could do is go ahead and just save out all of the toolpaths to run them on the machine. And the whole purpose of creating our toolpaths using this method of association with specific vectors and layers was to make use of the toolpath template feature. Now this layout is handy if we wanted to cut multiples of this design, where we could use the nesting feature to nest all the parts onto numerous sheets, and as we've associated particular vectors from each layer to each of the toolpaths, all we would have to do is recalculate all the toolpaths, which would create a set of toolpaths laid out over multiple sheets where we use the sheet space efficiently. And so to learn more about nesting, there is a dedicated tutorial that teaches you all about how to nest parts, and you can find that video in the related videos section for this tutorial in the tutorial browser. So now we can look at creating a toolpath template now that we have all of the toolpaths and they're all associated with vectors on particular layers. We could look at saving them out as a toolpath template. Now we could look at saving each individual toolpath out as its own template. Or we could look at switching on the visibility of all of the toolpaths and then saving all the visible toolpaths as one big template. And in the future, when you come to use it, even if the corresponding layers for the toolpaths don't exist, there's no need to worry, as the software will just go on to creating the next available toolpaths for you. And so in this case, we're going to look at saving all the toolpaths to one file. So let's switch on the visibility of all of the toolpaths, and we'll use this option here to save all visible toolpaths as one template. So we'll open that up, save that as the default name of samplecabinet.toolpathtemplate, press save, and as we've completed this file we could look at saving the file itself. So we'll go to File, Save As, and then in the project folder we'll call that one Sample Cabinet Toolpaths, so you can access that from there. Right then, so let's just go to File, Close. So we're going to look at opening a new file where we'll import vectors that have been created in the Cabinet Maker's software to demonstrate how we'd apply the toolpath template to future jobs. So we're going to demonstrate how we'd go about creating a new file with all the exported vectors that we've created in the cabinet design software. Now, some cabinet packages may have the option to export the vectors as DXF files, and others may export each individual vector as a DXF. And so we may end up with a lot of DXF files to import into Vectric software where it may not be done on a per layer basis. So let me show you. If we open an existing file and look in the cabinet design files folder, you'll see that we're displayed with a lot of individual DXF files, and they're still using the same layers that we created our toolpath template with. So we're going to look at taking advantage of one of the gadgets that comes with the software to process all of these into our Vectric product. So let's just cancel out there. So if we go to gadgets, and here we have a DXF Batch Processor, and if we click on that, that will open up the DXF Batch Processor gadget. Now, gadgets are little programs or routines that automate certain processes, and you can find out more about different gadgets that are available for your software at gadgets.vectric.com. So the DXF Batch Processor is going to create our job and import all of the DXF files that we specify in this directory that we're going to choose here. So we use a choose option. We're going to take that cabinet design files folder and OK that. Okay, then you can have the option to process subdirectories, and I don't believe we have any, so I'm just going to leave this checked anyway. Okay, so working down the form, we can go ahead and look at our layout control. Okay, so here we choose how many drawings in a row. In this case, we'll just go with 3. And we can specify a gap between the drawings in X and a gap between the rows in Y. And in this case, we'll just go and type in 4 for X along with 4 for Y. Moving on down for our actual drawing dimensions. Okay, so this is our sheet size. So I'm going to put in 96 inches here by 48 inches in there. And we'll specify our thickness. So we know that we've got this set up to cut a 3/4 inch material. Units we're working with is inches, X0, Y0 origin. We're going with the lower left hand corner, and we're going to set our Z off the material surface. Okay, and so once we're happy with everything here, we could go ahead and press OK. Okay, so here the software knows that we haven't loaded a job based on the settings that we entered in the batch processor form, and so it's going to create our job for us. So we can just go ahead and press OK. Okay, and so you can see it's imported 56 different files, and that's what it's processed. So here we could just go ahead and simply press OK there. Okay, so we can see that all of the vectors are overspilling our 96 by 48 sheet size. So we need to organise all of the vectors onto separate sheets of the material. And so to do this, we're going to look at nesting the vectors. So I'm just going to draw a box to select all of the vectors there, and then we're going to go into the nesting tool. Okay, now I'm not going to go into too much detail here, but for more information on nesting, there is a tutorial dedicated to this feature, and you can find that in the related videos section for this tutorial. Okay, so at the top we're going to look at the tool and clearance settings. So the tool we're using is a 3/8 tool. Okay, so 375 in there. Clearance, we're going to have a clearance of 1/4 inch in this case, and we'll go with a border gap of just 0. Okay, part nesting options. So we're going to rotate the parts to find the best fit, where we're going to do that at a step angle of 90 degrees, and undraw the option to allow parts inside other parts. We're going to nest from the lower left hand corner along the Y axis, and then we're just going to create one copy of these, and we could simply go ahead and press apply, and then we could preview that, and we can see all the sheets here. So you can see it's created 7 sheets, and if I double click on any one of these sheets, it will make that sheet the active sheet. Okay, so now that we're happy with the nest, we can simply press OK, and that will take us out of the form. So now that we've organised the vectors onto different sheets, we can now open up the Toolpaths tab. So I'm going to pin that out so that we have both the drawing and the Toolpaths tab open. We're just going to go over to the layers bar on the drawing tab. Okay, you can see all of the layers here, the same ones that we used to create our toolpath template, and you'll see that we also have layer 1 and 0 layer, and we can see, looking at the sheet, there are no vectors on these, so we could just look at deleting those. We'll just delete that one, and then we'll just delete this one here. So now we have all of the correct layers, we've got all of our parts. All we need to do is load in our toolpath template. So we're going to go in and we're going to use this option here, load toolpath template, and from the project folder we're going to open up that sample cabinet.toolpath template file that we saved earlier. Press open. The software is going to ask us if we'd like to apply this template to all of the sheets. So in this case we're going to say yes, and it's going to assign the toolpath template for all of the 7 sheets that we've got in our job. So we can simply go ahead and press yes. And so you can see that the software has processed our toolpath template and applied it to all of our sheets. And in our toolpath tree, you can see that the toolpaths have now been organised into groups by sheet. So we have sheet 1, which is this sheet here, and on this sheet it's only found the layer for the profile cutout, and so we can see the toolpath for that one. Sheet 2, so if we double click on sheet 2, we just take a look at that, you can see that it's pulled out all of the different toolpaths with their layers for this particular sheet. So you can see we've got all of those toolpaths and so on for the other sheets there. And so the nice thing here is that the software's organised all of our toolpaths onto their sheets via these tool groups. And so at this stage it would just be a case of saving out our toolpath. So we could take the profile cut for sheet 1, and then we could simply go in there and say save toolpath, and we're just going to save that toolpath out. In this case you could save it, and you might find it useful to actually create a folder here per sheet when saving out all of the toolpaths on a sheet basis. Okay, so we'll just cancel out there, and then we'll just close out, and you just save out all of the toolpaths for all of the sheets. And so you can see that by taking the time to create the toolpaths and associating them via their layers, we've actually managed to save a lot of time when creating toolpaths for sets of vectors in similar jobs like we have here, whereby we can import the original toolpath template and simply apply it to all of the sheets that have been created by the nesting feature. Okay, so at this point let's go ahead and save this project. So we're going to save this as DXF Batch Layout.crv so you can access this file from your project folder.